From the 1960s to the late 1990s, many mid to high-end cars were equipped with automatic retractable antennas. Today, let's use 3D animation to figure out how these powerful antennas achieve automatic extension, retraction, and stopping. Opening the cover reveals the simple internal structure: a motor connected to a worm gear, a drive wheel, a limit switch, a relay, and several sections of the antenna housed in a tube. Products from different companies and different time have significant differences in the design of the limit switch. The secret to the antenna's ability to extend and retract lies in the plastic wire with teeth inside the antenna. When the motor rotates, the worm gear drives drive wheel to rotate. The pressure bearing ensures the plastic wire closely adheres to the drive wheel, so that the plastic wire can move up and down. The drum at the back is used to store the plastic wire. The end of the plastic wire connects to the last section of the antenna. Each section of the antenna is designed with protrusions and grooves. When the plastic wire drives the last section of the antenna to move, the other sections will follow along. Now, let's explore how the motor automatically starts and stops. This is all thanks to the combined action of the limit switch and relay. But before we figure out how they function, let's first take a look at this special mechanical mechanism. This driving gear has a total of 8 teeth. For each 4 rotation of the driving plate, the driving gear rotates about 45 degrees. Although it differs in structure from a typical Geneva drive, its function is the same. Additionally, the driving gear is designed with up and lower lug at special positions. The limit switch has 3 contacts. When the upper lug of the driving gear reaches the position of the switch, the upper contact and the middle contact are disengaged. When the lower lug reaches the position of the switch, the lower contact and the middle contact are disengaged. The tail of the limit switch has 3 wires connected to other components. The middle wire connects to the positive of the car battery, while the up and lower wires connect to the relay. This double pole, double through relay played an important role in cars of that era. Some relays were used to control the headlight, while others controlled the windshield wiper, etc. Different relays vary in the number of pins and also have different purposes. To gain a more intuitive understanding of how the relay is wired and functions within the entire system, we have omitted other components in the circuit, such as resistors, capacitors, and so on. These 2 pins are used to energize the coil, with one end grounded and the other connected to the car radio's power circuit. The 2 common contacts are used to connect to the motor, controlling the motor's start and stop, as well as forward and reverse rotation. These 2 pins are called normally closed contacts. They are called normally closed because when the relay is not energized, the spring forces the 2 common contacts to remain in constant contact with them. The 2 corresponding to the normally closed, named normally open. Select one each from the normally open and the normally closed contacts to connect to the upper and the lower terminals of the limit switch, with the remaining ones grounded. Now, let's take a look at how the entire system works. Turning on the radio switch energizes the relay coil, causing the common contacts to close with the normally open contacts. Current from the car battery flows to the motor through the circuit formed by the limit switch and the relay. The motor rotates clockwise and extends the antenna. After rotating for a certain time, the lower and middle contacts of the limit switch separate, cutting off the circuit and stopping the motor's rotation, with the antenna remaining extended. However, please remember that this only cuts off the motor's power. The relay remains energized. Pressing the radio switch again cuts off the current from the radio, causing the magnetic force produced by the relay to disappear. The common contacts back to the normally closed contacts, allowing current from the battery to flow to the motor through the new circuit formed by the limit switch and relay. This switches the positive and negative poles of the motor, causing it to rotate counterclockwise and retract the antenna. After rotating counterclockwise for a certain time, the up and mid contacts of the limit switch separate, cutting off the circuit and stopping the motor's rotation. The entire system returns to its initial state.